Topic 11, DC Circuits, Part 4, Potential Dividers. The potentiometer, which is a type of potential divider. For detail, see the dictionary or watch this YouTube. The potential divider. A potential divider consists of two resistors connected in series with a supply voltage, like this one here. Instead of drawing the circuit like A, this one here, we'll normally draw it like B, which is this one here. Look at B here. As the current flows through the cell, it is gaining in electrical potential, just like gaining in gravitational potential energy. And as the current flows through the two resistors, it is losing electrical potential energy, just like losing gravitational potential energy. A potential divider can be used to control the voltage in parts of a circuit. So let's look at the circuit here. Let's say that we have a 12-volt battery and also a radio that works on 6 volts. So what we need to do is to divide this 12-volt into two halves like this by using two identical resistors, and so each resistor will get 6 volts. And if we connect our radio parallel to one of the resistors, let's say that one there, then the radio will also get 6 volts. Here is another potential divider with two resistors that are not of the same resistance. And to work out the voltage output V1, we just use a simple ratio. So if we put voltage output over the EMF, or the voltage put out by the battery, and that's equal to resistance 1, which is that one there, over the total resistance R1 plus R2. You can try this simple example yourself and write down the reading of each of the 3 voltmeters. 1, 2, 3. Thermistors and LDRs in a potential divider circuit. Thermistors and LDRs can be used as input devices. They can change their resistance depending on environmental conditions. We already looked at thermistors and LDRs previously, by the way. What is the symbol for each? Symbol for thermistor, symbol for LDR. It's for you to find out. You should know at this stage. Which one is sensitive to light, and which one is sensitive to temperature? Work it out yourself. We can use a thermistor to replace one of the resistors in a potential divider. So this potential divider, or this one here, same thing, will be sensitive to temperature. We can also use a LDR to replace one of the resistors to make the potential divider sensitive to the amount of light shining on it. Here is another potential divider with a LDR in it, and you can answer this question here, which says, how will the output voltage be affected by the decrease in temperature? Will the output voltage increase or decrease? For this potential divider here, how will the output voltage, which is there, be affected by brighter light? Will it increase or decrease? Potentiometer. You should have had a look at the dictionary regarding potentiometer on slide 2. If the two fixed resistors are replaced with one variable resistor as against fixed resistor, then a variable potential divider can be made. The volume control in the radio or the volume control in the TV is a variable potential divider, because you can get a continuous range of voltage output here by sliding this B, which is sliding contact, up and down like this. So it says here, if the sliding contact B is moved towards C, then full volume results. Moving B towards C, that's what happens. Less sound is heard when B is moved towards A. What actually happens is this sliding contact B divides the variable resistor into two parts, top part and bottom part. So as you move B towards C, the bottom part gets bigger and bigger, therefore has more and more resistance, and therefore the corresponding voltage output also gets bigger. Slide wire potentiometer. So instead of using variable resistor, we can just use a long piece of resistance wire for the sliding contact to slide along. So it says here, this device is used for the comparison of potential differences or EMFs. Here we have a cell of EMF E1, and then we can adjust the sliding contact here to find a point X where the milliammeter shows no reading. There is no current flowing through here. And we note the length here at 1. Then we replace this cell with another cell of EMF E2, say. And once again we'll repeat the process and find a different point X such that the milliammeter shows no reading. That means no current flowing through here. And then note the length here, L2. Then if we put the values into this equation here, we should be able to find out the ratio of these two EMFs. All this I have already explained on the previous slide, but I just want to draw your attention to this ratio here. Use this ratio to work out this example here. It says if E1 is 1.65 volts, E2 is 1.43 volts, and L1 is 0.75 meters, what's L2?